Yes, hello everybody and good afternoon. My name is Lise Øvreås, and as President of the European Academy Science Advisory Council, I would like to welcome you all to this launch of our latest commentary on energy system integration. EASAC unites the national science academies of the EU member states, in addition to Norway, Switzerland and United Kingdom, to collaborate in advice giving to European policymakers. Through EASAC, the academies work together to provide independent, evidence-based advice about the scientific aspect of European policies to those who make or influence policy within European institutions. Through our academy network, we mobilize the best scientific minds in Europe to assess pressing societal questions. EASAC currently has a focus on environmental issues, energy and bioscience, and public health topics. Today, the focus is on energy, with the launch of a commentary on energy system integration. It's a very timely topic, building on EASAC's extensive previous work on decarbonization and energy security. I will now hand over the word to our Energy Programme Director, Alessandro Allegra, who will guide you through this launch event and introduce our expert and speakers. So Alessandro, welcome.
Thank you very much, Lisa, and welcome to everybody. I will ask my colleagues to please put up the slides that we have. But in the meantime, I would like to welcome all participants today. And especially, I see many members of our Energy Steering Panel, the experts that provide the backbone of our work. And also, I know that who's joining us today is Bill Gillett, who was my predecessor in this role. So I would like to give him a special thank you for all the work that he has done for the EASAC Energy Programme in general, but specifically for this report that we are discussing today, this commentary on energy system integration that was produced under his watch. So before we start in earnest, a couple of words of housekeeping. As you have seen, the event will be recorded. Keep that in mind. And I will please ask you to turn off your cameras when you are not speaking or taking the floor, so that we can keep the focus on our speakers for today. There will be, of course, an opportunity. There will be an open discussion, an opportunity for questions after the main panel discussion. So that's going to be the moment when you will have the opportunity to engage. So hold your questions until then, and I will explain you how we organize the Q&A. So we'll start with a presentation of the key findings and recommendations of the report from the co-chairs of our Energy Steering Panel, Professor Neven Duić and Professor Paula Kivimaa. And this will be followed by a discussion with two experts who are kindly joining us today, Antonella Battaglini from the Renewables Grid Initiative and Maria Sicilia from the International Energy Agency. They will engage in a discussion with our experts and then with all of you present here. I will now give the floor to Professor Neven Duić, who will introduce us to the topic of energy system integration and its opportunities and challenges. Neven, over to you. And first of all, can you please move on to the first slides?
Thank you, Alessandro. It seems that Europe is lurching from one energy crisis to another energy crisis. And it's actually not energy crisis, it's fossil fuel crisis, which is quite understandable because we are importing 97% of oil and 85% of gas, which is a crisis in itself. It started to become acute in 2021 during post-COVID economic rebound, when Russia, our main supplier of gas, stopped supplying spot gas and starting to drain our gas storages. Then in 22, after aggression of Ukraine, it started to weaponize gas supplies. We are seeing now a new round of problems with oil and gas coming from the Gulf. The closure of Strait of Hormuz is a risk. It's a global risk. Europe is not importing that much from the Gulf anymore, but the price of oil and gas are fungible. So we have much higher prices now. So how to solve these problems? Europe is facing simultaneous compounding pressures of energy security, cost of living, industrial competitiveness, and impacts of climate change. EU has committed to net zero greenhouse gas emissions by 2050. So the energy system must support this transition while continuing to deliver affordable and secure energy. Today's system was not designed as an integrated whole. Electricity, heating, transport, and industry have largely been planned and operated in isolation. And this commentary is actually showing that we can solve all these problems with only one solution. One important problem to the transition is infrastructure. Grid infrastructure is not keeping pace with renewable deployment. In a way, we can see the price spreads between the markets, between electricity markets, zones, as a kind of proxy for congestion. If the price differential is high, that means these grid interconnectors are highly congested, and we should increase those interconnectors. But we also have other solutions if the grid expanding will go slowly, and that is integration. If we integrate our energy systems, if we coordinate planning of an operation of energy system as a whole across multiple energy suppliers, carriers, infrastructures, and consumption sectors, including heat, fuel, transport, buildings, industry, and everything, we can actually deliver much faster decarbonization. We can do it in an affordable way and a very secure way, because that would then depend on local renewables produced in Europe, and we could easily decrease the imports of fossil fuels. What energy system integration can deliver? Well, sustainability, that means climate change mitigation, affordability, the total price, the total cost will be lower, and energy security. Also, if we do integration, we need less grid. If we don't do integration, we need much more grid. The critical thing is to have lower fossil fuel dependency, because if we integrate sectors, then we can go to very high shares of variable renewables, which are available everywhere in Europe. And also this can increase the industrial competitiveness. Buildings can be active participants in the energy system, enhancing grid flexibility. So by electrification of heating, by storage of heat, also charging electric cars, building can become active part of the energy system and help increased integration of variable renewables. Transport electrification is very important. If we look at the rate of electrification of transport, currently 0.6 million barrels of oil are replaced per year additionally by the electrification rate. So we can quickly, by electrification of transport, reduce the dependence on imported oil. It also opens opportunities for flexibility because cars are parked most of the time, and smart charging and also vehicle-to-grid systems can strongly improve integration of variable renewables. That all opens a pathway to demand response, which is a critical technology which would be enabled by time-of-use tariffs and smart grids, and allow consumers to actively participate in electricity markets. Recent modeling studies that we consulted in EASAC confirmed that integrated energy systems are more cost-effective and secure than independent sector-specific approaches. So we should go for that. But there are barriers. There is grid congestion and inadequate infrastructure limiting integration of variable renewable energy and increasing dependency on fossil fuel backup. Also, there is increased cybersecurity risk. And one which is probably the most important point is that the resistance of incumbent fossil fuel supplier is based on their need to satisfy their shareholders' incomes, value increase, and on the other hand, they also have quite a lot of funding, and they can use that funding to lobby in order to slow down removal of barriers. So this is a very critical moment that we have to understand. There are outdated institutional remits of regulatory and administrative bodies designed to manage sector-based, largely fossil fuel energy systems. So we have to change that. Also, there is unfair cost-benefit distribution that risk that some will lose and some will benefit too much in the process of transition. So we have to think of the ways how to make this more balanced. Also, without long-term investor confidence into stable, credible, long-term policy framework, there will be problems with investment in long-term projects which are needed for this transition. I would like to pass the word now to Paula.
Hi, good afternoon, everyone. So my turn is now to talk about the EASAC's recommendations in the commentary, which draws on previous EASAC report. And I think many of the recommendations really also support where the European Commission is going with its plan. So first of and really importantly is prioritizing energy efficiency. And this is often stated, and the energy efficiency first principle has been there from 2018, but it's still lacking in many areas. So it's important that we have energy efficiency across buildings, industry, and transport while we move ahead with energy system integration. The second point is to protect ICT and enhance cybersecurity. And this is, of course, increasingly important when digitalization is advancing and different types of cyber risks appear more relevant. Thirdly, intensifying heat and electricity storage is vital, and as well as demand response to address the issues of intermittency in the increasing use of wind and solar energy. Fourthly, we recommend fostering stronger cross-border interconnections. In some areas, they are already quite good, whereas, as Neven pointed out, there's a lot of congestion, which can be a structural problem that cannot be solved by market measures alone. Also, what's important is really to enable time of use tariffs and demand response so that we still have member states, for instance, where end consumers don't have the possibility if they want to use spot market-based prices, which is quite good in terms of so that the demand responds better to the availability and non-availability of renewable energy. The sixth point, I will talk a lot more in a few moments. So supporting and engaging citizens and communities is important in this transition. And finally, we also recommend commissioning independent monitoring regarding the progress with the energy system transitions in the member states. Next, please. So as I mentioned, focus on energy efficiency, and this kind of obviously always makes sense, but somehow it's never politically so favorable as, for instance, increasing renewable energy, but it's really a foundational no regrets option, because at the same time, when it enables either reducing energy demand or at least curtailing the growth of energy demand, it benefits European energy security, energy affordability and sustainability all at the same time. So there's kind of these win-win solutions available, and then of course there are some sectors which have been quite hard, such as building energy efficiency, but also industrial energy efficiency, which are important. So when we advance with this electrification, we must make sure that we also take care of the efficiency aspects. And it also, what it means is, for instance, that while we do need to strengthen electricity transmission and distribution network infrastructure, the more efficient we are, the less demand there is for electricity. It also reduces the pressure on this grid infrastructure by reducing peak loads, for instance. But however clear it is, and there are existing policy frameworks to advance it, the implementation is slow and challenging in many member states, and I think we do need more work and also perhaps academic research on things that are slowing this development down and what could be done to improve it. Next, please. So I mentioned the focus on citizen support and engagement, and really while we progress that we also do it in a way that, for instance, we take care of the more vulnerable and low-income households in the transition so that they're not the losers. And of course, there are a lot of benefits with the energy transition. So a lot of the more distributed solutions, such as solar panels and heat pumps, mean that households and consumers can be more active energy citizens, and it will also increase their energy resilience in the times of crisis. But these solutions or funds for these solutions are not available to all income groups, so we need support schemes that target especially the low-income households. What's also important is that how the energy markets works, and also the whole how the energy system operates and how it becomes integrated. It's quite a complex and broad topic, so we need more accessible knowledge and information that is kind of for targeting the general public, giving them a basic understanding of energy systems and markets in this changing context. And this also is likely to improve the kind of acceptability of and increase the citizen support for these things. And also like understanding the broader context. So why is the energy transition, why we are doing it? It's because of the climate challenge, but also how current geopolitical uncertainties influence energy security, and it makes sense to reduce the impact of their dependencies on global fossil fuel supply chains. Next, please. And at the same time, we are of course having a dilemma when we have these energy price crises. So it's really important that whatever support we have for the citizens, it's correctly targeted and it does not distort energy markets in the long term. So for example, if we give tax alleviations or subsidies for natural gas in the times of price spikes, it actually gives a disincentive to try to reduce the use of natural gas. So therefore, when subsidies and other type of support mechanisms are designed, it would be important to design them in such a way that supports electrification and energy efficiency instead of fossil fuel use. And there's of course this long-term impact on the speed at which these energy efficiency measures, for example, are uptaken. Next, if I can't remember if we had, I think we had some further slides. Yeah, so really just to conclude, our message is integrating renewable energy sources better to the overall system, modernizing grid infrastructure, but also taking care of this energy demand response and energy efficiency can enable a faster decarbonization, reduce our dependence on volatile fossil fuel markets and supply chains, alleviate grid congestions, and lower energy costs for everyone. And it's also, it does not only benefit the individual consumers, but it's also a precondition for successfully delivering the clean industrial deal. So it can be done at least in two ways. So building and integrating industrial clusters for these win-win solutions. So when we design industrial policies and they should be oriented to industrial investments that improve circular economy, energy efficiency, and clean tech, which enable us with a more secure and sustainable energy system, but might also provide important competitiveness improving opportunities. And then while we support industrial, but also existing industries, it's really important that the European industries are electrified and to reduce the carbon dioxide emissions, but also improving the energy security. And in the long term, it's also likely to improve competitiveness when electricity becomes cheaper than gas, which is prices which fluctuate on the global markets. Thank you. I think that was my part.
Thank you very much, Paula and Neven, for providing this bird's eye view of the commentary on energy system integration. And in a way, the commentary in itself is a bird's eye view of what is a very complex and multifaceted issue. And as mentioned before, it builds on previous EASAC work on various aspects of the energy transition, especially our recent reports on security of sustainable energy supplies, on the future of gas, and decarbonization of buildings. So what you're hearing today is in a way the culmination of several years of work in this space, and of course looking at how these different sectors, these different energy sectors actually connect with each other. So today we have with us, we have the pleasure to have two experts who will be responding in a way to the recommendations laid out in EASAC's commentary. So I would like to welcome Antonella Battaglini, the CEO of the Renewables Grid Initiative. RGI, the Renewable Grids Initiative, is a unique collaboration of NGOs and transmission system operators from across Europe, which was actually established by Antonella with the mission to promote transparent, environmentally sensitive grid development to enable steady growth of renewable energy and the energy transition. So the work of RGI is really at the core of the issues that we're discussing here today. So it will be very interesting to hear Antonella's take on some of the messages from the commentary. And I think particularly one thing that came across very clearly from our analysis is that Europe is making good progress on solar and wind deployment, but not enough on strengthening electricity grids and flexibility management, which is needed to integrate them. So from your perspective, as you work daily with transmission system operators and NGOs, does this diagnosis ring true? And what do you see as the single most important obstacle preventing grids from keeping pace with renewables?
Thank you very much for inviting me, and congratulations for the report you have released. So we are talking about a very complex topic. Let me slice it down in pieces and start with your statement that Europe has made big progresses in wind and solar. I think the current energy prices that we see across the continent shows that it may be good, but not good enough. So we can definitely do better, especially in some part of Europe. And when you look at the energy prices in the south of Europe, which is plenty of resources, they are higher than the north. And this is definitely linked to political decisions in the past years. Now, the report points to the energy efficiency first principle. I think this is super important. My opinion is that we need to look at energy efficiency from a system perspective and not just of the single elements. And if we look at energy efficiency from a system perspective, obviously electrification results to be the most efficient fuel or way to fuel our economies. And this is the link to the grid infrastructure, because we cannot electrify without sufficient grids. I would like to remind everybody here that since the last 15 years, some 16,000 kilometers of cross-border or cross-border relevant kilometer of high voltage grid have been built, and another 100,000 kilometers are included in the planning made by ENTSO-E until 2045. The delivery of these quantities of grids is very difficult and also very costly. So I fully agree that the grid that we have now is not sufficient, and this is reflected in the report. But I also would like to stress the fact that we need massive and maybe even more larger investment in the distribution grids. And that we always need to understand why energy regulators approve or not approve an investment in grids. It has to have a positive CBA, cost-benefit analysis. And some of the projects are not realized because the CBA is not really there, or there are other elements. There is no supply chain, there is not permits. There are many, many different reasons for doing that. When it comes to system integration, I fully agree with the report. System integration is fundamental for decarbonization, but also for efficiency. I would stress the fact that we also need integration across all the voltage level, because we have seen a lot of effort in system integration, but still the low voltage level and the high voltage level are not properly integrated. When it comes to electrification, well, further expanding renewables and therefore also expanding the grid to accommodate these renewables, I think there are important aspects that need to be considered today, especially for large projects like in the case of the offshore wind, with volumes, investment volumes that are very important. In the past 24 months, we have seen no bids. And not because simply the grid was not ready, because there was no demand. There is no demand. So electrification is an incredibly important piece to reach decarbonization. And this is linked to the report recommendation to remove subsidies, support schemes for fossils and channel them into the electricity. I would say renewable electricity, if possible. So a focus on demand, I think it's very important. And finally, it is true that Europe is moving from one energy crisis to the other. I think the one that we should remember also is 1974, because it was quite a big energy crisis. And at the time, there was an internal report published by the Commission, which was basically indicating as a way to increase resilience in the European Union against oil shocks, was to electrify. 50 years have passed. Electrification rate is so low. So a focus on electrification is absolutely important. And I would also say a word of caution, because electricity and electricity systems are complex systems. They don't follow policy files. They follow the laws of physics. So we need to distinguish what is possible following the laws of physics and what is in the domain of politics. I hope that I've answered your question. Thank you very much.
Thank you, Antonella, for this very comprehensive perspective on the multiple angles of the issue, and especially on the strong need for electrification. Maybe Neven, Paula, would you like to respond, pick up on any of the points? I know that many of these have come up in our conversations before, so up to you which one you want to pick up, and then we can continue the discussion afterwards. Neven, please.
Thank you. I fully agree with Antonella that we are in a good situation, but this is very far from very good and even further from excellent. Around 120 gigawatt of projects are ready, but stopped in some way of planning. So we have a permitting problem that should be resolved. That also regards the grid extensions, which are also having problems with permitting. We cannot wait for a normal time of building grid in order to extend grid. We have to find ways how to make this project strategic and do it quicker. Otherwise, the transition will be bogged down. Also, electrification of transport is doing good, but it's very far from excellent. If we look at some leading countries like Nepal or Ethiopia or Southeast Asia, we are backward today in electrification. So why are we doing that? So there are questions which are linked to also our previous report, when we found out that very strong vested interests are slowing down the transition process.
Thank you, Neven. Paula, please.
Well, there was I think when you call for like a systematic approach or systemic approach on energy efficiency, and I think that's really important, but the challenge is of course great that when you have policies in different domains like building energy efficiency, where we do have EU regulation for new buildings, but the existing buildings are like the big problem, but also the fact that energy policy is still under member state mandate. So it's like, how do we, because all these different parts of the energy system are sort of targeted by different domains and levels of policies. I think that creates like a fundamental problem. Regarding, I just wanted to remark on the speeding up of investments. And yes, it's true, the speeding up is important in terms of making the processes more fluent, but at the same time, I don't think, and there's a lot of academic literature also on this kind of citizen legitimacy and justice questions. So it still needs to be done in a way that citizens are heard, and we have, because otherwise we'll really risk having adverse reactions to the speed. So it is perhaps not going as fast as we would like, but going faster than now, but then taking into account this participation, but also the other environmental values in question.
Thanks, Paula. I see Antonella would like to respond, so please, Antonella.
Very quickly, because everyone is making a lot of noise about the permitting, but the delays are mainly due to the lack of capacity by the permitting authorities. Everyone is looking at deregulating environmental legislation and societal engagement processes. This is not helpful. And also, if you put an order today for a cable, doesn't matter which voltage level, you will not get it before 2030. So why would you rush a permitting process, alienating people and alienating community, if instead you can do a good process, take care of the environment, and start your project once you get the cable? So we have to be a bit more critical and sophisticated. And this push for the regulation is creating huge amount of problem on the ground.
Thank you, Antonella, for this perspective. And I'm sure that many of these points will come up in the rest of the discussion. I would like now to invite Maria Sicilia from the International Energy Agency. She is the head of the Electricity System and Market Division. And of course, the IEA has done a lot of work in this area. Our commentary really presents the energy system integration as a package. We look at grids, market design, electrification, demand response, digitalization, and they all need to move forward together. But in practice, policy attention and investment are always scarce and sequenced, as was just mentioned now by Paula. Also, policy proceeds in silos and attention is limited. So it will be interesting to hear from your perspective, what do you see as the most pressing measures? The International Energy Agency has developed a 6-phase framework for variable renewables, suggesting that different measures are more critical at different stages of the transition. And based where most European countries currently sit, which I understand is kind of like towards the upper side of the framework, where do you think the main bottlenecks are? And do you think this aligns with our diagnosis that insufficient progress on grids and flexibility management are the main constraints?
Well, thank you very much, first of all, to give the IEA the opportunity to participate in this relevant event, and congratulations for this commentary. This is, Alessandro, a very important question, because it goes at the heart of how the energy transition unfolds in practice. The IEA's work shows that system integration is not a single measure. It's a combination of elements that need to evolve together, including grids, flexibility, market design, digitalization, and electrification of end use. But in practice, these elements do not move in parallel, and system progress through stages, and at each stage, different constraints become binding. This is what the IEA's framework on phases of variable renewables integration captures. In the early phases, the focus is on deploying renewables and ensuring adequacy. But as a system moves to higher shares of wind and solar, which is where many European countries now are, the challenge changes fundamentally. Importantly, it is no longer only about integrating renewables. It is also about integrating new forms of demand with very different characteristics, including electrification of transport and heat, but also increasingly large digital loads. This is an uncharted territory. What we are seeing now is a simultaneous transformation of both the supply and demand side. And from the IEA perspective, the central challenge today is the system's ability to operate efficiently, reliably, and securely under these new conditions. Grids and flexibility are clearly part of this, and many of the pressures identified by EASAC are visible in European systems today. However, the bottleneck is not only about insufficient grid deployment or a lack of flexibility in absolute terms. It is also about how effectively we use and orchestrate the assets we already have, and how new assets are designed and integrated from the outset. This means the challenge is not only to expand infrastructure, but to ensure that existing and new assets are utilized to their full potential. On networks, this involves both expansion and better use of existing infrastructure through digitalization and improved congestion management. There is plenty of congestion management that is a regulatory problem rather than a physical congestion. On flexibility, it means unlocking resources across the system, including demand. Demand response is very relevant. I fully agree with Professor Kivimaa's point that energy efficiency is a foundational non-regret option, but also at the individual level, incentives are today too low for households. And on top of that, governments don't want to expose consumers to the volatility of that inherently characterizes power markets. So that's also a shortcoming. It's important also to draw on storage, enhanced storage, and distributed energy resources, and ensuring these resources can respond to system needs. Critically, as new assets are deployed, they need to be integrated in a way that allows the full technical capabilities to be utilized. So to answer your question directly, yes, many European systems are now in a phase where integration challenges are becoming binding, but the constraints is better understood as a gap in system-wide optimization and coordination rather than simply a lack of infrastructure. In terms of sequencing, Europe does not need to slow down renewables or electrification, of course, but it needs to accelerate the evolution of the system around them. This includes expanding and modernizing grids, extracting more value from existing networks through the deployment of technologies that are already available, like grid-enhancing technologies, scaling flexibility, and ensuring that market and regulatory frameworks enable both existing and new assets to contribute fully. Crucially, this means rethinking how we ensure electricity security in a more decentralized and complex power system. As I mentioned, there are areas where we have technical solutions that are known and need to be enabled through policy and regulation. It's the case of these grid-enhancing technologies, but there are also areas where challenges remain, and particularly around the interaction between inverter-based resources and a declining share of non-synchronous or of synchronous machines in the system. This has major implications for system stability. So to conclude, what we see at the IEA is that Europe is now firmly in the phase where the challenge is not just building the clean power system, but operating it as a highly dynamic and optimized system, while continuing to deepen our understanding on how to maintain security as the system is evolving in real time. So I hope to have answered your question.
Thank you, Maria, for this perspective. I don't know if Paula or Neven would like to respond or pick up on any of the points raised by Maria. Please, Paula.
Oh, no, I don't have anything to add.
Neven, would you like to take the floor?
Yes. Well, in some countries, demand is already used as ancillary services, primary, secondary, tertiary reserves, which then allows better integration of renewables in a way. So this is already happening, but there are many issues coming from historic layout of the system. Our zones are not optimal. A lot of problems are coming because we are not in optimal bidding zones. So there is a lot of grid issues which are created by not having physical and financial electricity flows going the same way. So this is also another issue that could be improved. But one very important result of the last, let's say, 7 years of renewable build-out is that those countries that have a larger share of variable renewables and thus higher number of hours with marginal electricity coming from wind and solar, their prices of electricity mostly stay the same as before the crisis started. And those countries that did not invest enough now have double prices. And this is quite clearly seen on the map of Europe if you compare prices per zone in 2018 and 2025. And this is a very strong argument that we should quicken the transition towards renewables.
Thank you, Neven. And this is something that we have been discussing also over the past few days. This point of like the prices as the shock, let's say, to consumers and the shock that policymakers try to respond to. And now I've asked Cristobal to bring up the map that you have prepared. I mean, this is not part of the commentary in itself, but is a map that Neven had prepared, very much showing this difference between the countries that have electrified more than others. I don't know if Neven, with the map in front of us, is there anything else you would like to add? Or yes, I see Maria wants to take the floor, please.
I just wanted to briefly react to Professor Duić's comments that I fully agree on the point of the historic layout of the system. If we had to build from scratch modern power systems, probably it would look like very differently. But this is a challenge that we have to live with. And coming to the point of the impact of large shares of renewable generation in spot markets, this is very clear that those countries with larger shares are now shielded to a greater extent from volatility of gas prices. However, it is important also to consider not just the wholesale day-ahead market, but also the ancillary services market. And for example, in the case of Spain, as you may know, currently the cost of ancillary services is double the cost of energy in the day-ahead market. So overall, larger shares of renewables also have an impact on balancing costs.
Thank you, Maria. I mean, in a way, something like this, of course, is a great argument of sort of like we told you so, and with hindsight shows that it was a good move to not rely excessively on fossil fuels. But many of the solutions that we've discussed, that we've identified, have quite a long lead time before they bring benefits. Both the infrastructure and the regulatory reforms needed are slow processes. So I will be curious to hear from you if you see any quick fix or any quick win that could be implemented to at least take the edge off maybe some of the most acute issues. And I see that Antonella has her hand up, so I will give the floor to her first.
Yeah, thank you. It fits because actually I was thinking that, of course, the large project, the interconnectors, the enforcement of the grid, this is all very much needed. It's necessary, it's ongoing, but it will take still years to be fully realized if we ever manage to fully realize it. At the same time, I believe that we see an increasing role for distributed assets, and I stress the word assets is not just a generation, but also flexibility assets at distributed level, so that the local resources can be kept in the low and medium voltage level without being put up. This will not solve all problems, but definitely would alleviate some of the very local needs in certain regions. And one more comment about interconnectors, something that very often we fail to mention is that whenever we build interconnectors with large amount of capacity, we need to reinforce at the same time the grid, the lower voltage grid within the countries. And so this is also a cause of delay that enable or not the success of an interconnector project. So distributed generation, distributed assets, and definitely more investments at whole voltage level.
Thank you, Antonella. Paula?
Yeah, not a quick fix, but perhaps something to consider, which might be important in terms of gaining support or opposition for interconnectors is also that, of course, when a new interconnector is built, it benefits consumers in that country where the prices were higher, but it actually disadvantages those that were lower. And I think a good example was when NordLink was built between southern Norway and the UK, where Norwegian.
Paula, sorry, we lost you for a moment. Okay.
Yeah, my network connection went. So I think this is also connected to pricing zones, and I don't know if the European Commission or some other actors could or are working on propositions how to kind of then solve these pricing issues, or perhaps have some kind of benefit sharing schemes associated with interconnectors.
Thank you, Paula. So we have Neven first, and then Maria, and then Antonella.
I would like to go back to balancing power costs. Yes, in Iberian Peninsula, it is currently higher because of the layout of their system that is depending on all technologies for delivering balancing power, like gas turbines, which are usually turned off because there is excess of solar energy and wind energy during the day. But if we look at Denmark's solution to the problem, where boilers, electric boilers, in power to heat conversion are used for balancing, then we see very cheap solution. Of course, Spain does not need heating in summertime, but Spain has industry. So power to heat in industry could actually solve the problem of high balancing costs. But since electrification of industry was not pushed strongly in Europe, it's only starting now. The solutions have not been developed, but Spain looks like an excellent case point for power to heat in industry.
Thank you, Neven. Maria?
A comment on a quick fix. We are currently analyzing the retail price structure in OECD countries, and European countries stand out as those that apply the highest taxes and policy charges among our membership. This is a quick fix that is in the hands of governments if they want to make electrification more competitive.
Thank you, Maria. Antonella?
Yes, I fully agree with that. Maria, good point. I wanted to comment on the pricing zones because it is important to have this market mechanism. So we have an European electricity market that is envied by everyone around the world. So let's be careful of what we are asking for, because we don't want to kill it. And I know that the time is running, so I would like to add one new thought when it comes to infrastructure. Doesn't matter what infrastructure. Infrastructure is always built next to someone and within nature, the nature environment. And if we are not careful, we won't be able to build what we need. We need to build in a very responsible way, in a very inclusive way. And these are not costs. These are investments for the future. So this is my main ask, that we protect what we really value and have and build in the best possible way.
Thank you, Antonella, for this very important reminder that there is more out there than just our energy needs. Neven?
Of course, we have great markets, and we should not lose them, that's for sure. But there are better markets. If you look at the nodal approach to the markets, which is older and actually follows Kirchhoff laws, so they're more natural, because in nodal markets, electricity, physical flows are following the financial flows. Of course, I understand it would be difficult to switch to those markets, but North America and China are using them. It's feasible.
Can you explain, Neven, exactly what is the difference in these markets?
Yes, European markets are zonal. So you have a geographic zone in which wholesale electricity price is same at all parts of the zone. So if you don't have a very good, perfect connection between those zones, like, for example, between North and South Germany, then you have lots of flows that are being pushed through other countries, through other zones, just in order to satisfy the trades. In nodal markets, every single large transformation station is a market. And thus the physical flows of electricity fully follow the financial flows. And then you have this problem of optimal bidding zones. And there is a lot of discussion about optimal bidding zones, but there is a lot of resistance to move to them, which is again due to vested interests.
Thank you, Neven. And I see that Antonella is remarking that, of course, nodal markets are a good idea, but the French principle of égalité will be hard to overcome. And I think this really emphasizes a point that has come up a lot in the conversation so far, that sometimes, let's say, physics and politics don't fully align, or what will be optimal from an engineering perspective might not be necessarily the same from a political policy perspective, which is one of the fundamental challenges, I guess, of electricity market design, of energy policy, and also, I think, remarks the importance of scientific advice like the one produced by EASAC, but also the fact that ultimately these are deeply political decisions. So, unless there is any last point that any of the panelists would like to make to wrap up this conversation, I think we can maybe open the discussion with the audience. So, I will invite the audience to put up your hands. And okay, so I see that Bill Gillets is asking for the floor. So I will ask you, Bill, to turn on the camera and introduce yourself. Although I've already introduced yourself, but
So good afternoon, everybody. Can you hear me?
yes.
You can hear me?
Yes.
Yes, great. So first of all, congratulations, Alessandro and the ex-colleagues from EASAC for really interesting presentations and discussions. Thank you very, very much. My question is perhaps showing my ignorance, but I want to go to the point raised by Antonella, that if I understood correctly, you're saying one of the big problems with strengthening the grid is not so much what we've all been focusing on, which is the socio-economic dimension, but simply getting access to new cabling. Is that what you're saying? Are we in a situation where our supplies of cables are like our supplies of photovoltaics, that we depend on imports from a long way away? And what is Europe doing about this? And is this really a problem that we've missed? Because I don't think it was addressed at all in our work under the EASAC umbrella. Maybe I misunderstood. Thank you.
No, thank you for the question. It's a very relevant question. So we have a super good cable manufacturing industry within Europe, and we should not lose it. The industry has been invested billions in the past few years, so they have ramped up their ability to manufacture the cables that we need. But still, the growth in the demand has been massive, and therefore the timeline for getting cables, it's not like a supermarket. There is a long lead time. When you look at subsea cables for the offshore, which now we have commitment for up to 350 gigawatt of expansion, TenneT, the Dutch TSOs, had basically bought everything which is available. And if you want to push your project forward, you really need to buy cables outside of the EU, which this opens some security concerns. And of course, we would like to maintain a high share of European manufacturers in the bidding processes. So the cables will be there. There is a lot of capacity that is being installed, but the timelines are not immediate.
Thank you, Antonella. Maria, please.
Yeah, no, fully agree with Antonella. And just to complement what she said, there are very important global bottlenecks in the supply, in the components industry, is cables, but also transformers and critical minerals. And the IEA is tracking closely these supply chain issues, and also the lack of critical minerals. Copper is at record levels, for example, in terms of prices, reflecting the current scarcity. But we would be happy to contribute with IEA analysis if needed.
Thank you, Maria. Antonella, please.
Yes, and the current crisis in the Middle East, it's actually making this much worse, because it's not only a shortage of oil at the gas station, it is a shortage of diesel and oil products in all the supply chain that are needed for electrification. I was reading a report a couple of days ago that because of lack of sulfur, the copper mines in Chile are basically running down production. And if they stop, this will take years before they can start again. So availability or key materials is a very big point. And I think that if Europe wants to be energy independent, there is a very strong need for more circularity, much more reuse and recycle within our own border, because otherwise we move from one dependency to the other.
Thank you, Antonella. I see that Soteris would like to take the floor. So, Soteris, please introduce yourself and ask your question.
I'm a member of the Energy Committee of EASAC and member of the Cyprus Academy as well. And the last speakers talk about the Middle East crisis, and the previous speakers, of course, mentioned that as well. I would like to put another dimension to the whole story. Of course, I agree with all these findings about the grid problems, about the supply of goods and all these things. But there is one more dimension which is related to this silly, I call it, war that's happening in the Middle East. And the fact is that actually we're trying so hard for so many years to convince governments to put measures to lower the emissions from the power stations that use fossil fuels. And we have this threat of destroying all the oil sources. It is not the destroy of the supply, it's mainly the pollution that this will create. Because it's one thing to have a combustion through a normal process and have a little bit of, let's say, effluents that go to the atmosphere, and a completely different thing that burning the oil itself, which will go all to the atmosphere with all these huge problems associated with climate crisis. So this is an issue we should never underestimate, and I think we should do something as Europe to block this. We have seen until now some destroying of refineries, but not oil sources by themselves. But we have this threat on the table. We must do something as Europeans to block it, or not to allow it, to halt it. Of course, who is listening now from the government of USA to anybody else? But it's another story. This I would like to put this on the table if you think it's related. If not, just forget it.
Thank you, Soteris. Antonella, please.
Yeah, thanks a lot. Because I think this is fundamental, actually. There is no way we can decarbonize if we don't have a peaceful environment. There is no way that we can decarbonize if we continue to destroy what we have. Look at the emission of cement. Look at what is happening in Palestine and Lebanon. How much cement is being destroyed? I mean, that's devastating. There is no climate mitigation in a war zone. And this has repercussions everywhere. So I really appreciate you mentioning this. Thank you.
Okay. Maybe continuing on this kind of like more geopolitical angle and the issue of dependencies and supply chains, because that's something that has come up in some of our internal conversations. I would like to ask Neven and Paula about the views in terms of what the integration of the energy system and the full adoption of renewables entails in terms of dependencies, and how these dependencies are different from those from fossil fuels, and how they affect the energy security of Europe.
Yeah, the critical difference is that fossil fuels have to be delivered on daily basis. So we have a kind of daily dependence on or if we have storage for 90 days, as we have for oil, then we have a 90 days dependency. But for renewables, if we are fully dependent on imports of equipment, this is a decade level dependence. Because once you have imported solar power plant, it will produce electricity for 20, 30 years. Of course, it's quite important that Europe has its own capacity to build solar panels, but we don't really have to build them all because that would be too expensive. So the previous European policy to have 20 gigawatts capacity for solar panels production was a clever one. We keep the knowledge, but we let those ones that can produce it cheaper deliver it to the market. The new policy is even cleverer, I would say. It recognizes that China is now the market leader in production of panels, and it invites that 30% of panels are produced inside the European Union. So that increases security of supply of those panels. But of course, we will have to copy Chinese policy in the way they learned from us how to produce many things. Now times have come that we learn from them how to produce those things. So that would probably solve the problem. But anyway, renewables is equipment and fossil fuels is fuel. And this is a critical difference in security of supply.
Maybe I can continue in that, because of course the big debate is now critical raw materials, which we not only use for the energy transition, it's also used for digitalization more broadly, and defense armament and military armament and so on. But I think, and like Neven said, it's not a daily need, but it's still a big issue because so much of those materials are needed. And while we have some available in the EU, especially Northern Europe, they exist in much lower concentrations than in, for instance, the global south. So extracting them is much more resource intensive, and they're often in nature valuable, nature protected areas. So we will continue have, and the demand is envisaged so high, so we will continue to be dependent on critical raw material supply chains, a lot of them concentrated in Chinese ownership, if not in Chinese soil. So that's like a big issue. And that actually also further points to this idea of energy efficiency. The less infra we need, the more efficient we are, but also circular economy, recovery of materials is really important as well. And I think this is a huge area where a lot of development is needed. The other one is, I would say, a security risk is like skill space, like what Neven referred to, but how do we keep the skills and knowledge, not only the European production of, let's say, batteries or electricity transformers, and we have certain hubs, and I think we have to work on maintaining it. So it's not just like the physical issue, but I also see it as a skills issue, and that the same pertains to like cybersecurity risks.
Thank you, Paula. I see that Antonella and Maria would like to respond. And in the meantime, I invite any member of the audience who would like to ask a question or intervene to put their hand up. But Antonella, over to you.
Yeah, it's not really a response. I agree with everything that has been said. I wanted to add one thought that in every energy crisis, oil crisis, what we have seen is an expansion in investments in oil exploration. We have not seen what the report in 1974, the internal report of the Commission for Electrification. So we have to be careful, and I think that there is a very big need to have policy intervention in really pushing for electrification, renewable expansion, and grids, because otherwise we will not see decarbonization happening because there is too much money to make with oil. And the higher the cost of a barrel, the higher the investment will flow into that, despite all the risks.
Thank you, Antonella. Maria?
Yes, I would like also to comment on your question about new dependencies and fully agree with Professor Duić. Dependence on imports of clean technologies. There is a hardware component, it's a one-off, but we should not underestimate the role of the software in inverters, in transformer grids, and this is also cyber risks is clearly a source of concern. And according to the IEA database, 80% of targeted threats to any energy infrastructure is 80% is targeted at grids, and most of those are cyber attacks. So that's also a topic to take very much into account for years to come.
Thank you, Maria. And actually, our commentary on energy system integration and our previous report on security of sustainable energy supply very much look at these cybersecurity aspects. I don't know if Neven or Paula would like to comment on this specifically, or more broadly on the digitalization of the grid and what this implies.
Yeah, maybe better on digitalization than cybersecurity, but it's a very much interlinked issue. Smart grids, smart energy systems bring quite a lot of digitalization, but also we are living with digitalization in our everyday life, our mobile phones, computers, everything is linked, Internet of Things. So that increases significantly the danger of cyber attacks, and obviously we have to find solutions to that, either to have critical components produced locally under local control, or develop some other solutions. I'm not an expert in that field. But it is going to be strongly compounded because when we electrify everything, that will mean more or less 3 times more electricity than we use now. And this electricity use will be strongly controlled by digitalization. So this is a critical point. Not only in homes will be connected, but also industrial systems which will play on markets, day-ahead markets, intraday markets, ancillary services markets. So this all has to be protected.
Yeah, I could maybe just sort of say a perspective from the digitalization perspective. So I think the AI will be like a double-edged sword in a way, that on the one hand, we probably see more, and I know the development of more these AI agent-based balancing and direction of consumer responses. So AI would do it on behalf of like household consumers, for instance. But at the same time, we all know how much AI will increase the overall consumption of electricity. So while it can help us to make the system more balanced and also consumers to be more responsive, then we will at the same time increase the consumption of electricity in the overall system.
Thank you, Paula. And as we were discussing, this is something that probably requires more analysis for the future, but certainly changes the picture. Maybe to bring the discussion back to the latest policy developments, at the moment, as we know, the Commission has put forward a grids package, which is being discussed in the Parliament, and the President just the other day announced a new electrification action plan, which will be published in a few months. Maybe if I can ask Antonella, because I think you're the one who's like most on the ground with some of these. How do you see the current policy developments? Are they going in the right direction, and are they moving fast enough?
Thanks a lot. It's a lovely question. I've been spending so many hours on the grid package these last days. So first of all, do we have enough policies? Well, I really would like to see a stop on this policy formulation and really focus on implementation. Because every time we have a new file, there is so much effort put into that, but we forget about the implementation side. Without implementation, a policy file is only paper and ink. So now the grids package has been a very important development. It has created a lot of expectation, but once it was published, also created a lot of turmoils. And my analysis is that a lot of the people that support the grids package in its form do not understand what it means, the legal language, what implies the legal language. So the Commission has been proposing a central scenario. We don't understand what is central to what, because it is one and only scenario. All of you know that a scenario is not a crystal ball, it's not a vision of the future, but is one option. So energy regulators, investors, and even communities, they need to have more than one scenario to see and to understand the sensitivity, the risks, and the opportunity. And we are doing a lot of work to add these additional scenarios, and I think the Council has been already very, very unanimously asking for more than one scenario. Moreover, the grids package, it is exclusively referring to the selection of the PCI, the project of common interest. However, the way it is written is somehow replace the 10-year regulation, which leaves a kind of a question mark, is who's doing grid planning if that's only for the PCI. And the risk is that if it's not clarified, we may end up losing the European grid plan and then have 27 national plans that somehow will need to be put together. So there is a lot of very interesting suggestions, very good intentions, but the legal language does not reflect the reality where we live in and needs to be urgently improved.
Thank you, Antonella, for this analysis. Well, maybe I would like to ask if Neven and Paula would like to say any final words or thoughts. I think we can wrap up the discussion here unless there is any further questions or thoughts coming from either the audience or the panel.
I mean, I guess for me, from my perspective, I think the general, which is great, that the general need for system integration and the moving towards electrification is recognized. But I think what we do really need is perhaps all of us to be more on the ground and explain the situation in our own countries and to different actors to really get the backing, because I think that's what we need. We need the political backing in different levels, and for that I think also understanding the big picture is important. So I guess that's my conclusion. And I also, again, like I always in these discussions, I learn something new. So even as an expert in the area, you always learn something new, which also really shows how we're moving in a kind of a new and rapidly evolving area, which is then even harder for those decision makers who might not be experts in, or politicians who are not experts in this area.
Thank you, Paula. Neven?
To us, researchers who are working in system integration for the last 25 years, it was really a very happy moment when I heard a few days ago von der Leyen mentioning it in her speech, and also IPCC including the whole chapter on system integration. So it's finally getting into the open. And this commentary, I think it's excellently written, and it shows all the important points that have to be considered. It's a very wide field. It's very complicated because it integrates also different ways of planning and running different systems. and regulating them. So it will be difficult to implement, but it's critical to start strongly thinking about that. Thank you.
Thank you very much, Neven. And I would like to once again thank Antonella and Maria for taking part in the discussion today, for their insights and perspectives. Also thank all of the members of the audience who have followed this discussion and taken part. And of course, the various experts that contributed to preparing this report and the broader work of EASAC in this area. And I think with these, we can say goodbye for today. And hopefully, as Paula said, we've all learned something new and we're leaving with some new ideas. And I'm sure that you'll be happy with the 10 minutes extra that we're gaining on the program. Thank you very much.